Today we're reasoning through the impact of wind speed and direction on airport design and aircraft performance without hesitation, repetition, or deviation starting now. Aircraft performance is closely linked to the wind conditions during takeoff and landing. Winds are categorized based on their direction relative to the aircraft. A headwind is a wind blowing directly towards the aircraft. This is ideal for takeoffs and landings because it allows aircraft to achieve lift at lower ground speeds, reducing the required runway length. For example, an aircraft flying at a ground speed of 500 knots into a headwind of 100 knots would have an airspeed of 600 knots, enhancing lift. On the other hand, a tailwind is a wind blowing from behind the aircraft. While tailwinds are beneficial at cruising altitudes because they increase ground speed without requiring higher airspeed, they are undesirable during takeoff and landing. Tailwinds increase the required runway length as the aircraft needs more distance to generate lift. Meanwhile, crosswinds blow perpendicular to the aircraft's path. Crosswinds are common and aircraft must adjust their heading to compensate for being blown off course. This adjustment is known as the crab angle, which is calculated based on the strength of the crosswind and the aircraft's airspeed. For instance, if an aircraft approaches a runway with a crosswind of 25 knots and a landing speed of 135 knots, it might require a crab angle of over 10 degrees. To ensure aircraft can take off and land safely in varying wind conditions, airports design runways to align with the prevailing winds, which are the most common wind direction at the airport's location. This maximizes the likelihood that aircraft can operate with a headwind, allowing for more efficient performance and shorter runway requirements. Runway design is also guided by the windrows data, which shows the wind direction and frequency for the airport side. In cases where prevailing winds vary, airports may include crosswind runways. These runways are oriented to accommodate less frequent wind patterns that deviate from the primary wind direction. Crosswind runways are especially important for smaller, lighter aircraft which are more vulnerable to strong crosswinds than larger, heavier planes. For example, a small aircraft might be unable to land safely if crosswinds exceed a certain threshold, so having runways in multiple orientations provides flexibility and safety. While pilots are trained to operate in crosswind conditions, there are limits based on the aircraft's weight, landing speed, and the existing wind strength. Smaller, slower aircraft are particularly sensitive to crosswinds, and if the wind exceeds a certain limit, they may be unable to land safely. For this reason, airports serving smaller aircraft often provide runways in multiple directions to mitigate crosswind effects. The Federal Aviation Administration categorizes aircraft into aircraft approach categories, which are based on the airspeed at which they approach the runway. These categories help airports design runways that meet the safety needs of different types of aircraft. FAA guidelines require that runways accommodate safe operations for at least 95% of the annual wind conditions at an airport. If prevailing winds often create crosswind conditions that exceed safe thresholds, the airport must be designed with additional runways to maintain safe operations. Aircraft ground operations are influenced by the difference between ground speed, which is the speed relative to the ground, and airspeed, which is the speed relative to the surrounding air. Headwinds reduce the necessary ground speed for takeoff and landing, while tailwinds increase it. Ground speed directly impacts the length of the runway required for both takeoff and landing. In conclusion, wind speed and direction are critical factors in airport design and aircraft performance. Runway orientation is typically aligned with the prevailing winds to maximize the use of headwinds during takeoff and landing. Crosswinds pose a challenge, especially for smaller aircraft, so airports often include crosswind runways to ensure safe operations. By carefully analyzing wind patterns and designing runways to accommodate them, airports can ensure safe and efficient operations under a wide range of conditions.
If you like this video, don't forget to hit the like button, leave your thoughts in the comments, and subscribe for more aviation content.